Hi guys, welcome as we do this problem. Guys, we have a problem here and I can read first the details and then guys we look at the questions. And it reads, the masses of 40 screws, these are screws, in electrical workshop were recorded in table 1. So guys, here is our table 1. We have mass in kilogram, that is from 1. We have various classes, and these classes have the frequency here. Now guys, the questions we are supposed to answer are right here. So these are the questions concerning that, and the question is determine median, mean, standard deviation, first quartile, third quartile, interquartile range, and mode. And so guys, we now begin to do those questions. So guys, here we have our data, and as you can see guys, I have already tried to write all that we need. Guys, what we are given here is actually these are the class intervals from 1 to 1.9, all that. And from the class intervals, guys, we can develop class boundaries. Because as you can see, guys, we have some gaps. And so, guys, what we can do is that we could have a class boundaries. Because remember here, there is a gap between 1.9 and 2.0. And so then, guys, we decide that our lower limit for this is going to be 0.95. And the upper limit for the same class interval is 1.95. Guys, I have done that for all the classes up to this point. From there, guys, I have the frequency, and this is the frequency. And from the frequency, guys, I have also come up with a cumulative frequency right there at the end. Guys, we also have the midpoint of every class. The first class 1.5 and all those up to this point. Guys, we also have the fx. For us to get the first thing, which is the mean, guys, we will need the fx. As you can see the equation, summation fx all over f. So our fx is right here for each class interval. 8.7 for the first class interval, up to this point, and then we can add now to see summation of fx, which gives us 126. And from there, guys, we can now come to x squared. From the midpoint, we square, and then we can get the fx squared. And so, guys, those are the details for that. Guys, now we come for the mean. And for the mean, this is what we have. We have the cumulative frequency, which is 40, or the total number of items, which is 40. We have fx summation 126, and so therefore, guys, our mean mass is 3.15 kilograms. Guys, now going to the median. This is how now we approach the median. Guys, we first of all find the median class. Having 40, that is the total frequency, or we would say the number of items being 40 divided by 2. This now we get our middle class. And middle class is at 20. So we look at the cumulative frequency at 20, just above 20. And the cumulative frequency is right here. So we have 20. But remember, guys, now for us is now going to be the next class, which is now 3.0 to 3.9. Remember, the 20 is more than now 2.95, and so therefore, guys, it's going to be slightly above, which is now 3.0 and 3.9. So that is our median class. From there, guys, now we come and use this equation. We have the lower class boundary L, and that is it's at point. We have the lower class boundary of the median class. Guys, our median class is 3.0 and 3.9. And so at the median class, our lower class boundary is 2.95. And this is what we have right here. Going to n over 2, this is 40 over 2 gives us 20. Now guys, we are now comparing this and checking what n over 2, L and F means. For F is the cumulative frequency before the median class. This is our median class. So the cumulative frequency before that class is actually 20. And that's where we are getting our 20. Frequency of the median class. Our median class is here. The frequency is supposed to be 10. And then H is the class interval. And so therefore, guys, this is what now happens when we put in our figures. That is for L, which is 2.95. For N, which is 40 divided by 2, this comes to 20. For the cumulative frequency before median class, which is 20, it is right here. And then this is the frequency of the median class multiplied by 1, which is the class interval. And guys, now we are able to find the median. This is our median. Guys, now we continue. From the median, guys, now we go to the mode. And the mode equation is right here. Class of the highest frequency. For the class of the highest frequency, we have 2 here to 2.9, which has a frequency of 14. And this is what now we are going to use. And now, as we write this equation, we have L here, which means lower class boundary of the model class. The lower class boundary for the model class, which is this, which has a frequency of 14, is actually 1.95. And this is what I have written here. We have frequency of the model class. The model class has 14. And we have frequency before model class. Before model class, we have 6. And after the model class, we have 10. And this is what now, guys, we are replacing in this equation. As you can see here, we have the details. And then now we come and fill in the gaps here, where we have F1 minus F0, 2F1 minus F0 minus F2. And guys, here we have the lower class boundary of the model class. And finally, we get 2.62. So, guys, this is our mode. Going now to standard deviation. Guys, we now use this equation. Having that equation, we have fx, summation of fx squared 455.3, which is here, all over the frequency, which is summation of, or the total number of the screws, which is 40. And guys, this other one this is the mean squared. And that one gives us now, when we add up the figures together, we get 1.21 kilogram. Guys, this is the standard deviation. And now we go ahead. Guys, now we look at the first quartile. This is now quartile. And guys, for us, for the first quartile, we are now dividing the number of parts or the screws divided by 4. Remember, this is a quarter. First quarter is 1 all over 4. And this gives us 40 over 4, we get 10. So that is the first quartile. And we use cumulative frequency to find the class. Guys, we look at the cumulative, where we find 10 should be, that is our quartile, first quartile class. So the cumulative frequency is right here. We have 6 here. So guys, we are sure it's not here. And so it is right here. So our class is going to be now 2 to 2.9. And this is what I have written here. And we have the equation right there. For this equation, we have L, which is the lower boundary of the quartile class. Of course, the quartile class is right here. 2 to 2.9, lower class is boundary is 1.95, upper is 2.95. So cumulative frequency before the quartile class, that is 20. It's right here. The quartile class we are talking about is this. This is the class, so it's supposed to be 6. The cumulative frequency before the quartile class is supposed to be 6. And then we have frequency of the quartile class 14. And now guys, we can now put in our figures right here. Right here, and these are the figures. When we put in our figures, guys, we get first quartile as 2.24 kilograms. Guys, we now go to the third quartile. For that quartile, we still do likewise, guys, but now this is going to be 3 all over 4. For us now to go to cumulative frequency of 30 and find where we find our class. Guys, when you go right there, as you can see, we are right here. And this class is 3 to 3.9. And so, guys, this is our class. Guys, now we do likewise as we have done. This is lower boundary of the quartile class, which is 2.95. And here we have 3 quarter. Remember that third quarter is 3 all over 4. 3 quarter, we multiply by 40, which is now the cumulative frequency overall, minus F, which is cumulative frequency before quartile class. Before the quartile class, guys, we have 20. And then for the quartile class, we have the frequency of 10. And so, guys, when we do that, we will get 3.95 as our quartile, third quartile. Guys, from there, now we come to interquartile range. For interquartile range, we just subtract Q1 from Q3, and we get 1.71. And so, guys, thank you for listening to me. Bye.